Hi everybody, welcome. My name is Peter Marshall. I'm a technology evangelist in the Apache Druid open source community team at Imply. I'm very happy to be here today and to introduce you to our two speakers. We have Vijay, who is a senior field engineer at Imply, and we have Dharam, who's a data engineer at Avesta. We're just going to get straight into it. Everyone, although you're all on mute because you've just started, what I suggest we do is, as we go through the talks, please use the chat button somewhere on the screen, ask your questions as we go through, and then when each speaker's finished, I'll then field those questions for you. What else do I need to say? Just to say, if you're not in the Druid channel on ASF Slack, please join, come and say hello, follow us on Twitter. If you haven't got your company's name in lights on the project's Powered By page, then there's a bit.ly link there, Powered By Druid. There's a form you can fill in and the community team will help you set up your Powered By entry. If you haven't starred the project on GitHub, go and star the project because that looks cool. Email community@imply.io if you'd like to speak, or if you'd like to know about other events that are happening. And go onto LinkedIn and add Apache Druid as your skill, I think is the right thing to say. There's on the Druid project site itself, there's a whole list of other ways of getting involved in the community. And also there's the Druid University from Imply if you want to learn more about Druid. And if you're a coder and a developer, I would love you to go and have a look at the issues list on the Druid project website on GitHub and see if there's anything you can help contribute to. So without any further nonsense from me, I've stopped sharing. We're going to start with Vijay. Vijay, I'll hand over to you for your first talk.
Okay, let me share my screen real quick here. Okay, guys, let me get started here. As Peter said, I'm a field engineer here with Imply in the APAC regions. Of course, I have this slides for the kind of issues people face as they go about adopting it. Just hold on, let me just stop my camera because I think I have the bandwidth to do everything. Sorry about that. Give me 1 minute. Stop my video. Okay. So yeah, I mean, I do have this bunch of slides, but yeah, feel free to ask questions so that we can go on to topics and things that are not obvious here, but very adjacent to this specific topic of what the challenges people face when trying to adopt Druid, and what you can do to overcome some of those challenges. That's the agenda we have. So Peter, I'm assuming you will let me know if I'm running out of time. So just, okay, so yeah, when you're putting together Druid in production, the first thing is, of course, to define the data pipeline. Right? So this is an area where lots of people face lots of problems. In fact, issues, especially in ingestion, which are a direct consequence of the pipeline, are extremely common. And then you deploy it. Another big area where you can face issues, especially if you have the larger cluster. We talk about what some of the things that you can do about it. And then there are dependencies, including things like deep storage, Zookeeper, and of course the metastore itself. So these are some of the things that people go through, and then build the Druid cluster, use it to run the queries, and of course harden it and bring it into production, and then operate it on a continuous basis, monitoring. We'll have something to say about what you can do to monitor the system effectively. So these are the typical stages in adopting Druid, in your as your platform for accelerating queries. Right? So the build stage pretty much has the three things that you need to do: ingest data into Druid, manage and maintain the cluster, and then of course query it. And since the whole purpose is to really query very fast, querying, the ability to tune the queries become pretty crucial. Okay. So ingesting, maintaining or managing the database, and of course querying. Ingestion, of course, involves defining a schema, specifying a rollup, specifying filters, connecting to various source systems, and also tuning the ingestion task itself. So since you also know that in real-time querying, queries also are executed on the data that's being ingested. So the ingestion task also responds to queries or whatever data comes through in that particular time. The real-time data gets responded by the ingestion task. And then database maintenance, we have replication, what replication factor is set, distribution of the segments among the historicals, the distribution strategy, compacting, auto compaction, manual compaction, the issues around that. And then of course, tiering, hot and cold tiers. Of course, deleting data, overshadowing existing segments. Those issues also do come in when you're thinking of maintaining and operating a cluster. And lastly, querying. Querying primarily, of course, using the broker, using the router. Query performance, different types of queries, group by queries, joins, performance specific to that type of query, tuning the query. So all these things come into consideration. You're trying to actually adopt Druid. Now, this is an interesting picture here that the primary issues, I think Peter has done a survey, or it is from the questions asked on the community. The primary questions and issues people are facing are around ingesting, maintaining, operating the system, and of course querying. So these are the primary issues that people are facing. And if you think some of the questions, some of the patterns of questions, ingestion specification, how to write and generate them, execution of the ingestion itself, and then specific integrations with things like Hadoop or Kafka, parsing formats like Parquet, ORC, pretty common format, those two especially, and then ingesting from Kafka. What happens if the cluster goes down? Do I lose data that's already there in the topic? Where does it restart from? Issues around that. Those tend to be the big questions that folks are asking. And then, of course, in terms of monitoring and maintenance, metadata-related questions, auto compaction, and then distribution of the data in the various, among the cluster in the historicals. And of course, lastly, on the query side, query performance, and also the whole authorization, authentication, integration with LDAP, stuff like that tends to be very common issues. Query performance tends to also be a big issue. Then consuming results from Druid, either through tools like, for example, Superset, or even consuming, and I think that's showing up in the recent times is consuming in things like Spark, doing model training and things like that. So those are kind of issues that show up. So this gives you a good picture of what issues people are facing. More than half, around half the issues are all in ingestion, which at least some of you may not be surprising, but that has always been a little bit of a surprise to me, because I never thought of ingestion as a real issue. Usually you think of tuning queries as a thing that takes a lot of time and effort, but apparently ingestion is the biggest challenge around, and I'm at least somewhat surprised anyway. So yeah, so it's kind of interesting. So this is a bit surprising. The kind of questions that we get to see in terms of problems people face in running into a cluster, especially on the ingestion front. Compaction is likely one of the biggest, but I guess that's Even with the introduction of auto compaction, people do face some issues around that, setting it up properly, even auto compaction, things like that. And then, of course, making sure the throughput, you get the expected throughput. For example, not able to go beyond the 1 million average. And then ingestion getting throttled because intermediate processes were continuously happening, and because that ingestion getting throttled. And generally, improving ingestion performance. So these are all questions. So yeah, some of these may be familiar to you if you look at the group and also the community site. These are some of the questions that keep coming up. So what can you do about this, given that there are specific challenges around adopting Druid in the context of taking it into production? What can we do about it? So the first thing is to work with the entire pipeline. Don't think of Druid as an island. Especially think of what is the end result and how can that be achieved, right through various parts of the pipeline. So, for example, sometimes queries, there are things in the queries which can be pushed into the ingestion, right? So there may be specific operations, some kind of calculation, things like data sketches. Can they be pushed to the ingestion? So that's a question you need to ask. The consumption pattern in terms of querying, right? So is this going to be through a UI, or are there going to be scenarios where you extract a lot of data? So there are customers who extract. I mean, I recently had a customer who wanted to extract, I think every couple of hours they want to extract something like terabyte or 2 terabytes of data from the cluster, which is a lot of data to get extracted, because they are consuming and taking the data somewhere else and doing some additional things to it and additional processing. So those kind of requirements you probably need to identify right away, because otherwise what happens is that you end up either missizing the cluster or misconfiguring it. So this is important to keep in mind, that you need to understand the end consumption pattern and plan the other parts of your Druid cluster for that consumption pattern. So please keep that in mind. Some of the okay, yeah, some of the things to keep in mind are generally for business intelligence. Time is not a key dimension, but however, given the way Druid works, time is quite critical. So to be able to understand how the queries make use of time and how they can be changed to make use of time, so that you can do things like comparisons, for example. So that gives you interesting insights into what's happening to your data. And also, given that the data is partitioned by time, time matters pretty critically in the Druid cluster. There are queries that access all the data. They tend to cause a lot of trouble. So time is pretty critical. And then, of course, if you have thinking of filters and measures, so if you have dashboards with filters, for example, they can cover multiple contexts. So one visual can cover multiple contexts because of use of filters. And similarly with measures, right? So again, designing them carefully so that you get optimum use of filter and the measure is quite critical. And we're always focused on speed, of course, in Druid to speed up query performance and also data availability. So data coming into the cluster being available within something like 100 milliseconds. That's one of the key USPs of Druid. You don't want to have lag in your ingestion, so that it takes seconds for data to be available for queries. So these are some high-level things to think about when you're designing a Druid cluster. So Druid is not an island. This is something that's obvious, but I've been in many situations where we had to go back and rework something because we didn't realize certain dependencies. So Many things to be considered here depending on the nature of your deployment. If it's self-hosted on the cloud, if it's bare metal, different considerations, even arcane things like especially security, for example, the authentication chain, what kind of authentication chain you're going to use. So all these things that to keep in mind. Druid is definitely dependent on lots of upstream and downstream components. So keep that in mind. Here is an interesting consideration on where Druid fits into a broader data pipeline. Right? So this is not, it's maybe some new to some of you, not so new to others, but if you think of a data pipeline where data is picked up from where it's being produced, delivered into some processing engines, and then stored in a data lake, and finally available for querying. Where does Druid really fit in, right? So this is something to ask. So you have typical delivery tools like your Kinesis or Kafka or things like Event Hub pops up. Lots of different tools available for delivery of data. Very common these days in general. And then processing data, common engines, Spark, maybe Hive, and then storage, more and more moving towards object storage, whether on-prem or cloud, or of course traditionally with HDFS. And finally, being able to query. But traditionally, this was done using things like Hive, maybe some of the search engines. But this is where Druid fits in. It is a platform for computing statistical calculations and doing really fast queries on the data. Right. So this is where this fits in. So it's important to think of all these upstream components as you design a Druid cluster. Different customers have different ways of doing things. I mean, there are some things that come to mind when I think of upstream. For example, because of the fact that without Druid, many customers have a challenge in aggregating on the fly. They tend to push aggregating into the processing layer and try to do a pre-aggregation in Spark. I've had multiple customers doing that sort of thing. So clearly, that's an area where you can add a lot of value in when you're deploying Druid by getting rid of those kind of pre-aggregation so that you can do aggregations on the fly in Druid. Since the whole purpose of having a platform like Druid is to be able to do all kinds of ad hoc queries. So you lose on the power of Druid by pre-aggregating data in these other platforms. So this is something I've had to point out to customers again and again in a number of scenarios to avoid unnecessary pre-aggregation in upstream tools. And if you have to pre-aggregate, it's probably a better idea to do a roll-up as the data comes into Druid, or keep granular data for a short period and then roll up by re-indexing within Druid for the older data. So those kind of capabilities will make the querying a better experience for the user than trying to pre-aggregate in the upstream, especially pre-aggregation in Spark. In the context of these search engines, seems to be a very common thing among many customers who had challenges in doing OLAP with these search engines. So they tend to pre-aggregate in Spark, and that is something that one can profitably get rid of when you are working with Druid. So that's something to keep in mind. Yeah, so this is what where Druid fits in as a platform for accelerating queries and allowing users ad hoc exploration of data, and that's what we need to focus on. So this is the typical pipeline: going into Kafka, doing some processing in Spark, again coming into Kafka, and then going into Druid. The one thing in the context of the pipeline to keep in mind is that while joins are available in Druid, extremely heavy fact table type of joins really still don't work. I mean, they are not going to give you great query performance. So again, it's useful to think of doing denormalizing data as much as possible in the data processing pipeline so that you can focus on high-speed queries within Druid. So this is something also to keep in mind. Okay, so some of the more details of what to do to avoid getting into issues. The JVM properties are pretty critical, especially heap size plays a big role in making sure queries perform well. So please go through this basic cluster tuning guide that's available. It's quite detailed, and I've generally found it extremely useful. Even now, I keep referring to it whenever I have a doubt. So very, very useful. It's not like set in stone, but gives you a nice guideline and starting point for some of these JVM, especially on the JVM side, and generally on setting things like the threads, number of threads, buffers, and those things. So very useful thing to keep in mind. So these are some of the key things to bother about as you are setting up a Druid cluster. Your number of threads, HTTP number of threads. This controls the concurrency, because the HTTP thread essentially on the broker side, it opens HTTP threads to communicate with the historical. On the historical side, it communicates with the broker. That's the broker and historical communication through the HTTP thread. The buffer size and the number of merge buffers are quite critical for group by queries. So if you are doing group by queries, you want to keep an eye on this merge buffer, because group by queries require at least one merge buffer per query. If you have single top level query, if you have subqueries with group by, you need 2 merge buffers per query. And of course, the buffer size is important because that controls whether the process of merging. So again, just to kind of see why merging is required. When you're doing group bys, you're obviously aggregating data. The first aggregation is at the level of the segment, and then there is merging them across the segments, and then merging across the historicals in the broker, and all of that depends on the buffer size and the number of merge buffers. So by tuning the buffer size up to a maximum of 2 GB per buffer, you can make sure the merging process does not page to disk, and that can speed up group by query. So these are some things to keep in mind. Of course, using cache on the historical would be very helpful. Again, specifically in the context of group by queries, they're extremely helpful. So these are key properties in the historical side. And of course, your heap and the direct memory. The direct memory essentially is controlled by the number of merge buffers and the size of the buffers. So these are kept in mind as key memory parameters of the historical. And on the middle manager, again, similar parameters. You can see that here. Then there are specifically for each task, you can see the indexer properties, each task having the buffer and the number of threads. So typically, you will have 2 threads and 1 or 2 buffers per task. That should be enough to both ingest the data and answer any real-time queries. So some of the other things, I think that's pretty much what this key properties are in terms of memory. This, in fact, covers all the memory-related properties on the historical broker and the middle manager. Right? So this controls both query performance, especially in queries like group by queries, and also concurrency. So both are controlled by these memory properties. So you need to understand those parameters. So what's the expected concurrency I have, and design these things appropriately, right? So that's kind of to keep in mind. So again, Druid is, as you know, a highly distributed, loosely coupled system. This is one of the core strengths of Druid, and therefore Zookeeper especially comes into play a lot. And we keep forgetting. I've myself done this in one of the recent projects. I actually had Zookeeper issues because I was running single node Zookeeper, and then those went away when I started running Zookeeper in Ensemble in a cluster. So keep an eye on Zookeeper, make sure it's not getting overloaded. If necessary, run it in a Zookeeper cluster so that it can be healthy and handle whatever is required. So lots of communications go through Zookeeper. So first is the broker identifying what are the segments available on what historical. That's one of the communications that can go through Zookeeper. Historicals, then publishing information, the whole coordinator making sure what are the historical nodes available to assign segments to, and then historicals. So that information going to the coordinator and then coordinating, assigning segments to the historical, that goes to Zookeeper. So lots of other, generally all the overload communicating with the tasks, that goes to Zookeeper. So lots of things go through the Zookeeper. So keep an eye on Zookeeper when you are running a Druid cluster. This can be by personal experience, I know that this is often an issue, especially if you have somewhat of a medium size. So anything beyond 10 nodes, and you need to be careful and keep an eye on what's going on Zookeeper and make sure that's in a healthy state. Right. So logs, you have multiple logs. You have your overload, middle manager, and task logs. These are for ingestion. And then if you are doing queries, you may want to look at the coordinate and historical log. And also a thing which I found very useful is to enable request logging on the broker and see the actual query that comes through into the broker log. So the broker will, if you enable request logging on the broker, it will start logging the queries that come through. And especially if I'm looking at SQL queries, and then the broker will show you what is the SQL query, what's a native query, very useful. And if you are using external systems to do query, for example, if you query from Spark, and you really want to know what's the query that actually goes to the broker, it can be very useful in debugging issues, so that request logging can be extremely useful. So yeah, I mean, start with the quick start, which is available. But remember, the quick start has got configurations which are more for a demo, a small kind of a lab. It's really not a production configuration. So if you're want to use the Druid production configuration, that's available in conf and not conf-quick start. So just make sure you use the quick start to kind of get up going quickly, get a feel for things, and then switch to the other configuration, which is more for a production type of configuration. So keep that in mind. Yeah, ingestion specification, definitely you need to have a list of all the queries you're going to be running. This tells you what, so I'm currently working with a customer who's got a really crazy 3-page query from Spark, and we're trying to move it into Druid. And clearly, I'm not going to put a 3-page query into Druid. The plan would be to move some of these things. For example, they have string concatenations, date formatting. So I'll push all that into the ingestion layer. So that's one of the things you can do if you know what are the most of the queries you'd be running. And then you need to understand your schema, what columns, data types of the columns. Obviously, string types are being indexed, while so you need to. I mean, some columns can be both a string type and number type. So necessary to, especially to those columns, decide what type you'll be using. Do you have lookups? And then what aggregations can you do at query time? Can you create sketch columns to be used for distinct columns? So those are kind of questions that you need to understand and answer when you are creating your ingestion specification. And then whole question of whether you use group by queries, you want to use top-in queries. Group by queries are very flexible, but not as performant for other queries. And then if you have to use group by queries, a number of parameters available to tune them, so those things keep in mind. Then of course, execute queries and monitor performance. And then you can tune the queries, tune the various memory parameters, tune the number of threads, tune the buffers. Right? So that's something to keep in mind. And can you filter the data at ingestion? And of course, the whole question of what is the minimum granularity you need? Can you do a roll-up? Clearly, roll-up is extremely powerful, but also you lose information when you do roll-up. So that trade-off of performance versus the level of granularity you need, that needs to be kept in mind. So these are some of the things to keep in mind. Of course, I can talk forever on this, but I'm just going to move on. And yeah, so definitely ingestion is quite critical and is very related to what your query pattern is and what you can live with in terms of querying. What's the sort of the minimal viable product in a combination between the ingestion specification? What can be pushed into ingestion and what can be done in the query layer? So that's important to keep in mind. And that usually, that's one of the things you need to iterate over. So you may start with fairly simple ingestion specification, but you realize when you start querying that there is a need to push certain things into the ingestion layer so that the query can move much faster. So that's a iterative process which you need to go through. Definitely need to understand your segments. This critical trade-off between having lots of small segments or having very large segments. So key thing is that the segment scanning is done as, one segment is always scanned by one thread. So if you have a very large segment that you cannot achieve parallelism, like you may not use all the threads you have available. On the other hand, you have extremely small segments, you will have significant overheads where bigger segments will be waiting to get scanned. So it's basically a U-shaped curve, and you need to hit to the bottom of the U. That's a very critical part in doing tuning when you have, especially for query tuning. Okay, so this is a few thoughts here. Some of the thoughts on the segments. Again, nothing new, but hope that definitely worth thinking about again and again. Filtering of the rows, and of course, what dimensions we really need, what can be dropped. And then, of course, segment granularity and the number of rows, maximum number of rows in the segment. Control them carefully to achieve an optimal segment size, especially keeping in mind how many threads you have overall in your historical, and hence what's the parallelism you can actually manage. And then, of course, query granularity rollup, pretty critical. Tiering, load and drop rules, rolling up into the warm and cold tiers while having no roll up in the hot tier. So all very useful things to think about. And from a planning perspective, think about not only capacity for ingestion, but also reindexing. Reindexing is as heavy as ingestion. So you need to plan for it. If you're going to do reindexing, say at the end of every day, I'm going to do a reindex so that I roll up the data. So you need to definitely plan for it. And compaction. Compaction is very critical. Set up auto compaction properly so that segment size continues to be well maintained right in the cluster, and consider doing manual compaction periodically if you find that segment sizes are going completely off. So that's in mind. A few other parameters here on the task: max bytes in memory, max rows in memory, intermediate persist period. Intermediate persist period is again one of those things which basically are a trade-off, right? If you keep persisting too often, then your ingestion can slow down. If you persist too rarely, then you have too much data in memory. So that's also not good depending on how much RAM you have and stuff like that. So keep that in mind. Yeah, so these are some of the things to keep in mind when you are designing the Druid cluster. Of course, you have the community. People already briefly mentioned that you're all probably already in the community. So reach out to the community. And there's a fair amount of documentation, and of course, you can always ask questions in the community. And this is the website and email. And of course, the last bit, which is quite crucial, is enable metric logging in Druid so that you can start collecting metrics. Druid has an extensive set of metrics: query runtimes, CPU time per query, segment scan times, extensive set of metrics. So collect the metrics, and these are all the metrics that are available. This is the documentation on the metrics. So very useful when you're doing performance tuning. Imply has a UI built on the basic Druid metrics, which gives you a very nice visual way of looking at these metrics and understanding what's going on. That's another powerful tool. So reach out to Imply if you have issues monitoring and tuning, because Clarity, which is the application performance monitoring monitoring layer, gives you the ability to monitor these metrics using a UI. So please keep that in mind. Okay, I think that's pretty much it. So I guess I am on time. Let's see. Yeah, I'm pretty much on time as well. I can see. So I'm going to stop that here in chat.
Wonderful. Thank you, Vijay.
Right.
So please ask your questions in chat. I see that Itai, you're answering some questions. Thank you.
I would have had Itai. Maybe Itai, do you want to say something to the folks? I guess
nothing special. Just there were a few questions about aggregations and approximations in Druid and versus Elastic actually. And the main thing is that yes, you can get exact count with Druid, but of course there's always trade-offs. Personally, I find that the data sketches and different sketches approximation is usually good enough for most of the use cases, and it gives you the best performance. So I would go with that. But that's it.
Also, generally, I have seen, so specifically to answer some questions on Elastic, what I've seen customers do with Elastic is pre-aggregate data. Now, that tells me that doing aggregations in Elastic is definitely nowhere near as easy on an ad hoc basis as it is in Druid. So that's what we've seen with customers. So even without aggregations, Druid tends to be without the approximations, Druid tends to be very good at aggregation, because approximations are primarily for distinct counts, but there are other aggregations, and Druid tends to be much better at it than pretty much most of the engines out there. And we can spend a whole lot of time on why Druid is actually better for architecture, but I'm going to leave it out right now because I want Dharam to also talk about it.
I heard you volunteering for a talk there, Vijay. Thank you. We have another question in the chat. So is there a limitation on the number of columns in each data source inside Druid?
There is no such limitation, but again, remember, there's going to be price to be paid, and there's a question of what's that trade-off for you, performance versus, of course, you can have like thousands of columns, have like a massive, I don't know, 1,000-node cluster, and everything will work well. But there is no basic limitation. There'll always be a trade-off with these kind of things.
The biggest, I don't know about you guys, but the people here, but my biggest lesson working with Druid, apart from auto compaction, is definitely around optimization of the segment sizes. And for me, that comes up a lot in understanding fundamentally how big they are, how to shape them, and make sure that because you've got the right number and the right size of segments, that therefore leads to good query performance. And the more columns that you have, the higher the possibility that those segments are going to get quite large. So that's, to me, there isn't like a logical limitation on the number of like columns you can have in a segment. That's always my concern, is how big are those segments going to get. But anyway, well, we must move on. Thank you very much, Vijay. Thank you, Itai, and thank you for your questions. We're now going to hand over to Dharam. I'm looking forward to this talk. Thank you, Dharam. So if you'd like to start sharing your screen, we shall get going.
Yeah, sure. So thank you, Peter. I hope yeah, so starting with the, first of all, thank you for joining this Meetup talk. I hope everyone is able to see my screen.
Yeah, we can. Go ahead.
Yeah. So our talk is on Apache Druid. So starting with the company profile, like Avesta Technologies specializes in providing end-to-end consulting and development services for cloud-native modern applications and analytics. And we also have a few in-house products as well, and we customize them as per the client's need. We have presence in various sectors of the industry like education, IIoT, digital marketing, etc. And the fun fact is, we have been using Druid, or we have discovered Druid since it was in 0.14 version. And since then, we are working on Druid. We are using Druid, and currently we are in 0.19 version right now. And about me, so I work as a data engineer at Avesta Technologies, where I take care of all the data analytics and machine learning related requirements. And I basically manage everything, like starting from gathering requirements, then development, infra setup as well, deployment, and then maintenance. And all of these is possible because I have best of the minds as my colleagues, uh, and my core technology stack includes Apache Druid, Apache Superset, Apache Airflow, Apache Kafka, Apache Flink, OpenCV, and TensorFlow. And it's been 5 years since I was started my career, and that's it. Now, now, moving on. So why Druid actually? So Druid is at the core of the analytics solutions that Avesta develops, and but actually we started off we started for a database which can help us in building our IoT platform. So our a few of our so we need something which is based on the time, and also it should be really fast. And we came to do it. We have also evaluated other tools like ClickHouse is there. But what set Druid apart is the vast and active open source community, and it's one of the main factor, or one of the only factor why we chose Druid at the first sight. Then Druid is really fast, both in terms of data ingestion and data query, and it's and Druid enables interactive analytics as well, and it is easy to get started with Druid. Yes, so it's quite. It's difficult to explain like how Druid is easy to get started. But what I can tell you all about from my experience is that most of the configurations and settings that come out of the box for Druid will just work, at least for the POC, at least for the POCs. And as you get started with Druid, you will also find that it will also require less human interventions as compared to other tools like ClickHouse is there, Apache Pinot is also there, even at scale, because of few of the features like auto compaction is there, then rebalancing of segments, which is done automatically by Druid, and such other uh, features of Druid. Then uh, Druid requires minimal uh, infra resources, so it saves you quite a few dollars. I mean, and if you are going at scale, a lot of dollars actually. If you compare to Elasticsearch, ClickHouse, Elasticsearch has a actually huge infra requirements, and also it's bit complicated as well. If we compare it to Druid, then Druid is extremely scalable as well. So this is why Druid was a go-to database, or a go-to tool for us at Avesta. And now, so how we are using Druid at Avesta? So we have two of the use cases wherein we are using Druid for ClickStream data analysis. One is digital assessment for answer books, wherein we have a recommend of real-time dashboarding on progress, how many answer books have been assessed, or how many are there in progress, and so on. Then the key thing, like identifying potential flaws in the system by analyzing events, which is something is very important, because what we do actually is really critical because a lot of students' future is dependent on us. If our system has some potential flaw or something is going on and we couldn't find, then it will be it can impact a lot of lives as well. So we are using ClickStream data analysis to find those potential flaws, to find something suspicious uh, with our product. Then we are doing web analytics for a real estate client overseas. So we are doing website traffic analysis using Matomo, and for Druid, and the Druid we are using for live dashboards and reporting as well. And I will be walk you through our uh, web analytics for a real estate client use case. So starting with the architecture. So I'll be explaining both the architectures. Like for the real estate client, we are using batch ingestion, and for our in-house product, we are using real-time ingestion. So traffic is coming from actual websites, then mobile application is there, and backend servers as well. And we are using Matomo for our client to capture clickstream data. So Matomo basically stores the data in MySQL, and we are using Apache Airflow as a workflow scheduler, and we have written a few jobs in Apache Airflow which pulls in the data from MySQL and dumps it into Apache Druid. Then another use case is we are using DVOLT as a collection data capture tool, and Druid has DVOLT has native support for dumping data directly, root data directly to Apache Kafka topic. And Druid has also native support, native connector for Apache Kafka, which it can get data directly from Apache Kafka topic. And from Druid, we are using Apache Superset mainly for showing all the dashboards. Apache, and what we have found from our experience is that Apache Superset is one of the most compatible tool with the Apache Druid out there in the market. And for open source tools, among open source tools. And we also have analytics APIs built on top of Druid to cater our reporting needs, and also to serve few of our other admin panels with the states from Druid. So how we are achieving this with the as little infra as possible. So we have five, uh, I would say five servers. So we have Matomo server. We have a group of Matomo server wherein we are using two T3 medium servers uh, uh, hosting the Matomo, and we have one master server that is also T3 medium, and Superset and or Airflow are also deployed onto master server. And we have two query servers, both are T3 medium, two data servers, T3 medium, and one monitoring server, T3 medium. And this monitoring server is also shared among other services as well for our client. And as you can see, like we have deployed Zookeeper onto three of our Druid servers so that it will be in a quorum. So it will help us in fault tolerance. Then we have node exporter running on all these servers, C advisor running all this. These are a node exporter and C advisor are for the monitoring, and rest are the Druid services. So in terms of the EC2 servers, we just need these many servers. So if I talk from Druid perspective, we just need uh, we we uh, we have 5 servers running, 2 query, 2 data, and 1 master. But you can start with 3 servers as well, 1 master, 1 query, and 1 data server. Now, what else you will require is Amazon RDS or any MySQL uh, DB. So for our use case, we have MySQL server, Amazon RDS, and it is hosting all the Matomo data, Druid metadata, superset metadata, and Airflow metadata. So we just need one RDS server. That is MySQL. We have Amazon S3 bucket as well. That is for holding all the segment data from Druid. Then it also stores all the Druid logs and also stores Airflow log. Then we need a code repo for all the configurations and Airflow job files. And also we are using Druid exporter, that is a Prometheus exporter for Druid metrics by Wikimedia, which is also open source. So this is all you need, and uh, these all the things we are using for our client, for our use case. Then here's some actual production numbers. So we have been we are ingesting data in at 3 frequencies. One is every 15 minutes, one is every 1 hour, and one is daily. Then we have 2 data sources basically. One is for raw data and one is for rolled up data. And here are some stats. We do not have that huge use case, as you might have heard from other talks and meetups and all. But yes, we are trying to keep the cost as minimum as possible for our use case and to achieve the optimal use of our Druid cluster. And we are serving around at max 240 requests per second, 240 queries per second into historical, and around 100 queries per second with the broker. Uh, you might be wondering why there is a difference between queries at historical and queries at broker, because we are using for reporting needs, we are using a union operation as well in a single query. So which for so that query goes to broker and it is split into multiple queries and sent to historical. So which is why, and we are very happy with what we have achieved, because our 95th percentile average response time is less than 500 milliseconds at broker, and it is very well within 200 milliseconds at historical. And so we are using a node exporter for basic monitoring of the nodes. So we have 5 servers, Druid servers running, and we are using Prometheus and Grafana for all the monitoring needs, and we also set up the alerts in Prometheus as well. Then we are using Druid exporter by Wikimedia to capture all the Druid metrics into Prometheus. So it's a simple Python server kind of, and what it does is it gets the data from Apache Druid uh, and it rewrites into Prometheus supported format, and Prometheus pulls the data from that Python API server. And here is a sample for metrics dashboard we have created in Superset. Actually, we have quite a few other dashboards as well in the Superset created, and Superset is too good for when working with the Druid actually. So what next? As you have, as you may be wondering that we only have a ClickStream data analysis use case, basically for Druid, but that's not all. Druid can be a good choice for a lot of other different use cases and scenarios. Basically, for us right now, it is like if we are in need of a time series database, if we are in need for a real-time columnar database, we'll blindly go for Druid first. Then, if it is not suitable or we have some special requirements, then only we'll go for other. So, what are our future plans, sir? I mean, we have already started preparing Druid for various of our other projects. First is IoT, Industrial Internet of Things, which was the initial project for which we started discovering databases and found Druid. So we are again back on the track for IoT. Then we have another marketing automation project, and another use case is customer data platform that we are in process to build for one of our clients. So coming to the real deal breaker, the main motto of this talk, like why why Druid and how Druid can help you with your real-time data analytics requirements that is too well within the budget. So, as I already explained, it is really easy to get started with Druid, and it requires very less human intervention. So it saves a lot of precious man hours, and you can just start with one human resource as well. Uh, like us, it was just me at the first, and who started with the Apache Druid, who taken up the initiative to build a Druid cluster, to set up Apache Druid for our use cases and all, and also working on other things side by side as well, like writing Apache flow jobs and building superset dashboards. So it's not like you will need a team of data engineers or data analysts or software engineers. It's just one dedicated person you will require to get started with the Apache Druid, and minimum infra required to get started with Apache Druid, that is two at production level, I would say, will be well within $200 a month, just $200 a month. And also on top of that, Druid is very well suited for multi-tenancy. So if you have multiple use cases, if you have multiple clients who have requirement for the Apache Druid, you can bring all the data from those clients or those use cases into a single Druid cluster. And this also ensures the optimal use of Druid cluster and sometimes overuse as well. So it's not just big companies that can do analytics at scale, but every company can now. And uh, of course, all thanks to Druid. So that's it. And you can connect with us. You can contact us for if you have any questions or if you want to know more about our use cases or how we are using Druid or anything. You can just you can head over to our website, or you can just send me an email, or you can send an email to our company email as well. So that's it. Over to you, Peter.
Wonderful. Thank you very much, Dharam. Thank you. Okay, anybody have any questions? Please just ask away in the chat channels. Just to get everyone started, I have a question for you straight away, Dharam, which is on the Grafana dashboard that you've built that's showing all the metrics for the stuff that's going on in Druid. Have you found particular metrics to be more important than others? Are there any that you particularly have got an eye on all the time?
What I mean, first of all, I look after the node health because we are running too many things on a single server. So I'll keep an eye on CPUs and RAM and all. And from the Druid perspective, I always keep an eye on how many queries at max we are getting, and also what is our average latency, or what is the response time we are serving the queries within.
Cool. Yeah, it's I think metrics are often missed as a way of making sure that Druid is performing very well. So I'm glad to see that you've got that under on your cluster already. Any other questions for anybody? Thank you very much. Any other questions from anybody?
Hey, Dharam, what kind of queries are more common in your Druid cluster?
Queries based on we have real estate client. So we have main needs of reporting. One property is there, so they want to know how many times this property is viewed, or how many times users have interacted with these properties, and so on. So one is for the reporting needs, and the another one is to analyze actual traffic coming to the website, or I would say uh, a, GA alternative, Google Analytics alternative.
Okay.
Hello.
Hi, Roger. Go ahead.
Yeah, what is the size of data messages which were analyzed, or the data size and throughput you could achieve?
We have around 890 millions of rows in total, and if I say it's around 28 GB of the data in the Druid cluster that we are analyzing, or the query gets executed on.
Wow, great, thank you. And how do you compare this in the cost, with the Snowflake?
Sorry, compared to what?
There is a Snowflake. There's another product for data analytics, Snowflake.
Actually, I would not recommend to compare Druid with the Snowflake, because Snowflake is more or like a data warehouse, or Druid actually fits to data lake side more or less. And
Okay,
so
what do you
if you
compare
want
with?
to really
Droid
compare
is
Druid
similar
with
to which other product?
ClickHouse.
I'm sorry?
ClickHouse it is. ClickHouse.
Can you please type it if you don't mind?
Yeah, sure. It's a ClickHouse, and Apache Pinot is also there, but we have not explored Apache Pinot that much.
Okay, thank you.
It's a good question. Thank you. Because so my background was in data warehousing. Other people might chip in here. My background was in data warehousing. I hadn't really come across time series databases. And if I'm completely honest, I'd never used a columnar database either at the time. So I was in big business that moved very, very slowly. But Druid is kind of a bringing together. It's like a mashing together of what you'd expect in a time series database. So it's got great time comparison querying capabilities. If I want to compare what happened 5 hours ago with what happened 5 weeks ago, for example, or I wanted to split my measures down into something I can analyze based on periods of time. So it does time series, but it does columnarization. So in that way, it's a little bit like columnar databases, so that you can do statistics very quickly. And it's also, and that's a little bit like a data warehouse, but because it also has functionality to associate with, say, a log search system, because the ingestion is also independently scalable, you can also ingest real-time data at very high volumes into Druid. So it's a bit of a mix. I think my perspective, and Itai and Vijay might want to chip in as well, my perspective is it's like having a data warehouse where everything has time as a dimension, and where you can ingest very large volumes of data for it to be analyzed using time as a dimension. And yeah, someone else say something.
So maybe I can weigh in a bit. So the the key question to ask yourself in these kind of situations is, how much does query performance really matter for me? So, I mean, I know of customers who actually, and I worked with them to effectively to tune the shit out of the cluster to get to about 200 milliseconds, because that's really critical for them. But if you tell yourself, okay, 5 seconds, 10 seconds, it doesn't matter to me. It's okay. 5 seconds, okay. 10 seconds, okay. Then you need to really think about, whether you need a platform like Druid. The query performance, to what extent really does it matter is something, because ultimately something like Snowflake won't be able to achieve the same performance in terms of cost, right? So if you think of price performance, then Snowflake does not compare to Druid at all. But if your performance is not that key, I mean, it's okay to kick off a query and have a cup of coffee and take it easy. I mean, there are use cases where that's okay. I'm not saying that every use case needs that 100, 200 milliseconds. And that's kind of where the sweet spot for Druid is. It is really hot, really hot analytics. You're not even talking warm here. So that's my perspective on this.
Yeah. Thank you for that question. Any other questions from everybody? We've got a few minutes to go. Okay, wonderful. I'm very, very grateful to having had the chance to speak to you all today. Hello from the UK to my friends. I've just shared the screen here just to say again, please follow us on the Twitter handle Druid.io. Have a look in GitHub. Have a look at the other ways of engaging with the community. There's Slack, there's Google user groups, there's the dev list, and also go and have a look at the free training if you want to learn a bit more. And there's lots and lots of videos on the Imply website from the Virtual Druid Summits. There's 4 of them this year, believe it or not. So if you want to hear more from me, I'm all over them. But there's loads of videos on that site as well to give you a bit more background into Druid. So thank you very much, speakers, and thank you very much for joining today. Thank you very much, everybody.
Thank you.
So,
Bye-bye.
Thank you.